Question 44. Sketch the graph of the following function. F of x equals x minus 2 all over 2x minus 3 times x minus 2. So this graph is already factored for us. It is a rational function. So the first thing that I'm going to do is cancel out the common factor. And as we probably know, this can be simplified to f of x equals 1 over 2x minus 3. But we need to state that x cannot equal 2. When we cancel out a common factor, we need to state that. So at x equals 2, that's where our hole is, right? When we have a common factor, that usually means a hole. So I'm going to figure out the coordinates of that hole or that point of discontinuity, however you want to describe it. So what we would need to do is find f of 2. When we find f of 2, do not substitute it into the original because we get 0 divided by 0. Substitute it into the simplified expression. So if we're finding f of 2, of course that is 1 over 2 times 2 minus 3. Well, that's nice. 1 over 4 minus 3, which is 1. 4 minus 3 is 1. 1 divided by 1 is 1. So just to get the coordinates of the hole, it's 2, 1. So we'll draw a hole at 2, 1. So 2, 1 is a hole. And let me select the pen tool here. There's a hole. It's a big hole. All right, going back, let's continue on. So we got a hole. The other thing, of course, that we want to figure out are our asymptotes. And we could look at either form. But in the non-common factor, that will represent a vertical asymptote. So we know that in our vertical asymptote, we want to solve the non-common factor. So our vertical asymptote, we get 2x minus 3 equal to 0, 2x equals 3, x equals 3 over 2. So I'm going to go ahead and draw that. So x equals 3 over 2, of course that's 3 divided by 2, which is 1.5. So 1.5 will be about right here. And then we want to draw our dashed vertical line all the way through. And when we're drawing our curve, we're mindful to follow asymptotic behavior. So some other things about this graph that we want to find is our y-intercept. So when you find a y-intercept, we know x equals 0, and we can substitute it into either form. It's easier to substitute it into the simplified form. So f of 0 is 1 over 2 times 0 minus 3. So that's negative 1/3. So our y-intercept is at negative 1 over 3, which is approximately right here. All right, let's make that a little better. Seems it's my last graph, a third. Let's zoom in. So a third would be approximately, negative a third would be approximately right here. Nice dot. Okay, so this actual graph is a pretty basic one. It's 1 over 2x minus 3. So it's really just a transformation of 1 over x. I'm going to substitute in a few points now and plot those. So just for reference, right, the 1 over x graph kind of looks like this. That's the basic form. So this is just that graph shifted over, basically. Try to have it a little more accurate than I have. So let's substitute in the 1. Okay, so we'll substitute in 1. A little bit of mental math here. 2 times 1 is 2. 2 minus 3 is minus 1. So at 1, it goes down to minus 1. So we'll put that in. And you could see now that this curve will have asymptotic behavior. So I got the 2 I got done. I'm going to do the 3 just to make sure. So if we substitute in 3, again, mental math, 2 times 3 is 6. 6 minus 3 is 3. So we get a positive 1/3. So at 3, we're getting a positive 1/3. So let's put that in. About a third of the way up. And there we go. So this graph, much like its parent function, has a horizontal asymptote right on the x-axis. It's not shifted up or down. And we could see that by the equation. This is really the last thing we'll do here. As x gets really, really big, we get 1 divided by pretty much infinity, right? 2 times infinity minus 3 is infinity. So 1 divided by infinity is 0. So this has a horizontal asymptote of x equals 0. So I'm going to put in my horizontal asymptote, and I'm going to finish off this curve. So some people don't put in the horizontal asymptote if it's on the x-axis. I like to put it in, especially if you ended up having to shift it after. So we're just going to obey the asymptotic behavior. It obeys the horizontal asymptote on this side of things, and then it obeys the vertical asymptote on this type side of. Likewise over here, it's obeying the vertical asymptote. Make sure you're drawing a function. It's swooping around and obeying the horizontal asymptote. Just for fun, I'll write in some points in case we don't see them. 2, 1, 0, 1/3, and I believe this was 1, -1, and this was 3, 1/3. So this is a nice, accurate graph, and it should get us full marks once we draw the arrowhead on here.